Okay, welcome to the first lecture for logic. This is a general introduction as to what logic is. It goes over the general structure of logic in the course before we get into the actual content of the course. These lectures are supplements to the written things in Laulima. Lecture 1, I have it already there, and I'm just going to read it through. This is a video version for those who prefer a visual presentation of the material, and I should have these kinds of videos for most of the lectures, not all, but most of them. So here we go. What is logic? Logic is the study of inferences. That's a pretty broad definition. What's meant by inferences is just everyday kinds of uh, behavior patterns that we engage in, whether it's conscious or not. The major types of inferences, there's two types, explicative or deductive and ampliative. Before I get into the two types though, let's illustrate this with a common sense example. You go out drinking one night with friends in Waikiki, it's Friday night, it's late, you come out of the bar and you see in the distance, it's hazy, you can't see very well, plus you're drunk. And you see someone stumbling around in the distance, and your natural inference, it's not something conscious, it just happens, your natural inference is that the person's drunk. But do you know for sure that's the case? No, you don't. Maybe the person is disabled and they're walking in that strange way because of that fact. Or maybe they're a Waikiki performer doing the drunk dance when they're not drunk at all. The point is, we make inferences on a daily basis, conscious or not, all the time. What logic's trying to do is step back from that playing field, that natural playing field, and then try to systemically and systematically represent some of the inferences we make. We can't capture them all, there's too many, but we try to capture what we can so that, in a sense, we're not enslaved by our inferences. We're not enslaved by the trajectory of our thoughts. We, as it were, shine a light upon our own process of thinking so that we can better understand how our mind works. That is part of what the study of logic is about and why it's important and why it's practical, if you think about it. Okay, keeping that in mind, there's two major types of inferences, once again, deductive and ampliative. We're going to be studying mainly deductive logic in this course, but ampliative inferences also enter into this course here and there. But keep in mind, it's deductive that we're mainly after. What makes an argument deductive or ampliative has to do with the structure of the argument. So first off, let's get some terminology straight. What does it mean by argument? This right here, this line down with that going across, that represents, that's the symbolic notation for an argument. And an argument contains premises and a conclusion. Okay? What we mean by argument in logic is not people yelling at one another or in disagreement. Rather, argument is a rational structure by which claims are made. It involves assumptions or premises, which is starting information, and a conclusion, which is inferences that are drawn out of those assumptions. Okay? Keep that in mind because we'll come back to that over and over in the course, and I'll give you some examples in this lecture as well. Okay, so once again, deductive reasoning is what Phil 110 covers. Logic splits into two sides, ampliative and explicative. Ampliative inferences split into two sides as well. There's what's called inductive and abductive. To get a sense for what these kinds of inferences are about, let me give examples. So I'll give an example first of a deductive argument, and then I'll go on to give examples of inductive and abductive arguments. What makes a deductive argument deductive is that the information, the conclusion, is already contained in the premises. The idea here is that your conclusion is somehow latently already within the information that the premises contain. If it's already there and latently sort of being drawn out, well, you might ask, what's the point? Why do we bother with deductive arguments? Since if the conclusion is already contained within the premises, it's sort of like, okay, fine. Turns out the most powerful application of this is in mathematics, which is anything but easy. And almost all mathematical inferences are deductive. The conclusions you're drawing out, you can think high school geometry for those who took it, or any kind of proof in mathematics, or any kind of chain of reasoning that you engage in with symbols, with equations to come to a conclusion, to come to an answer. That's all deductive. That's what this general pattern is about. Logic, it turns out, is the glue, the glue of reasoning, and logic is thereby the study of that glue that undergirds mathematics and a whole series of other disciplines. Here's a simple example of a deductive argument. It's the standard philosophical favorite. So here are your premises. All people are mortal. Socrates is a person. If you don't know who Socrates is, he's considered to be one of the great initial Western philosophers. Socrates and Plato, they sort of go hand in hand. And he's even sometimes called the founder of Western civilization. We'll get to that maybe a little bit later in the course. So anyway, if all people are mortal, all of them, and Socrates qualifies as one of these things, a person, then thereby Socrates is mortal. That conclusion has to follow. The conclusion is contained within the premises. That's what makes for a valid, or sorry, a deductive inference. On the other side, if you remember the diagram, we have an ampliative argument. An ampliative argument basically is the opposite or the inverse of a deductive argument. A deductive argument deduces or draws out information from the already contained in the premises, whereas an ampliative argument amplifies. It goes beyond what the premises contain to a conclusion that's stronger than that. And if you think about it, that's most of our everyday types of inferences, right? If there's any kind of risk involved in an inference we make, we bet on the stock market, we think tomorrow's going to rain, so we bring an umbrella. Those are all ampliative inferences, even if we don't recognize them as such. Ampliative inferences have two subtypes, what's called inductive and abductive. Let me give an example of each to illustrate what this terminology is about. An inductive argument is there's a pattern in your sample, and then from that you project it to the general population. Here's a simple example. There's 1 million swans. They've all been white. Now you go to a new continent and you find that this population of swans is also white. You're a naturalist, let's suppose, and you travel all around and you're documenting for the first time these things called swans. You think you've counted up enough and you've seen this regularity enough, so you then conclude, naturally, all swans are white. That's the pattern of induction. This kind of pattern also occurs in polls. If you remember the recent presidential race, all the expert pollsters said, look, in all these various states, for all the various counts that matter, we project that Donald Trump is going to lose the race to Clinton, and as a result, they claim that most likely Clinton will win the race, right? But that wasn't guaranteed. That doesn't happen. So the point here is what makes an inductive argument inductive is that there's a regularity in the sample, and you project it to the general population. In this case, swans are white. All swans are white. But what makes an inductive argument ampliative, as contrasted with deductive, is that the conclusion is not guaranteed. And in this case, even if you see all these swans and they're white, and it's natural to think that all swans are white, there's an easy counterexample. There's something called, there's black swans in Australia, but you see them all over the place. They've been transferred around the world, so it's not the case that all swans are white. Okay, for an abductive argument, the pattern there is there's information in the premises, and the conclusion tries to find the best explanation putting together the information in the premises. Yeah? Here's a simple example. Suppose you're in class taking logic or whatever class it is, and then you walk outside and you notice the pavement is all wet. And then you feel around, it's really muggy, humid. This being Hawaii, and you just came from class, the natural best explanation for that is it was raining. Is that guaranteed? No, because it could be any number of reasons that the pavement is wet. Maybe the sprinklers went off, and it just happens to be a humid day, but it wasn't in fact raining. But still, it's a good explanation for what happened, but not guaranteed. All right. The above map, in essence, is what logic is about. We're going to spend most of our time in the course focusing on deductive arguments. What makes a deductive argument deductive, besides the above initial characterization I gave, is this concept of validity, okay? And you need to memorize these definitions. They're going to show up on the midterm, and we're going to be applying it over and over and over again throughout the course. I will hammer this home to you guys for the remainder of the course, but it's good practice to start to try and memorize it now. It's deceptively simple. It doesn't sound like there's a whole lot there, but it's actually quite complex when it gets to when he gets to unfolding this definition in terms of its applications and doing proofs and a whole series of other things. Okay, so here's the first definition of validity. Assuming that the premises are true, not that they are in fact true, but you're hypothetically entertaining that the premises are true. You're saying, suppose for the moment that's true. The question you're then asking is, are you forced to the conclusion? Must the conclusion be true? If the answer is yes, that you are forced to the conclusion on the assumption that the premises are true, then the argument is valid. The second definition that follows from this, they're equivalent, although this second one is harder to understand, and I'll come back to it later to try and give you guys some examples to help explain why they're equivalent and what sense the second definition makes. The second one says it's impossible for the premises to be true and the conclusion false. So keep in mind the first definition, then using that I'll try to explain why the second one makes sense. Okay? So the first definition says, again, assuming the premises are true, the question is, are you forced to the conclusion? Well, let's suppose you are. Assuming the premise is true, you're forced to the conclusion. So then let me ask the next question. When the premises are true, assuming you're forced to it, right? Can the conclusion be false? No. So the idea is that it's impossible to have true premises and a false conclusion. Why? Because you're forced to the conclusion. So it has to be true on the assumption that the premises are true. That's why the second definition of validity is equivalent to the first. If that didn't make sense to you, don't worry about it. The other major definition that follows from the definition of validity, building on top of validity, is what's called soundness. It's a second way to evaluate the goodness of an argument. An argument is sound when, first off, the argument is valid. So you have to apply that definition up here. And then secondly, you have to figure out, are the premises in fact true? Are they really true? Whatever that means. If it is, then you get something stronger than just validity. You get what's called soundness. Okay, again, in this course we focus mainly on validity. These other ones are important. This second definition you need to know. Soundness is also important, but only in a secondary sense. It's validity that you really need to know. Alright. That's the end of the first lecture. In the second lecture, what I'm going to do is take you through the installation of the software, getting registered with the grade grinder, and a whole series of other things. So be sure to check out the video for that. Remember, all of these things are also contained in Laulima. It is strongly recommended that you go through the reading materials. That's like slow digestion. If you go through the reading materials and the picture files and the audio files and all those things that I have in Laulima in the module section, you're going to have a better sense of what the concepts are about. But if you feel like video is your way to go, then I will also have a series of videos as well. It should also be noted that in my lectures, in the written lectures, I have video links to certain problems and whatnot to help you out. So there's a whole host of guides there for your various learning styles. Videos are good, but the primary thing that you should all try to do is do the reading. That slowing down of the mind, that getting into your brain, that hard work and process, that self-discipline of logic, that's part of what logic's about, and it's a good practice to get into, and it has many additional benefits besides just working the problems. It has longer term consequences. So like eating good food, you don't much care for it, but it's good for your health. You don't feel it initially, but in the longer run, it proves to be better for you. Logic is kind of the same way. I know it's not great news, but everyone should have a bit of logic, especially in this day and age where if you look around on media reports and whatnot, it seems like people have less and less logic. So have some logic. Alright, I'll see you next lecture.